we understand the bucketing tables, partitioning tables along with the bucketing tables. Okay, I want to make sure that you understand these two things before we get into the other queries basically. Okay, first thing is assuming that there are no partitions as well as there are no buckets. There is no bucket as well as there is no partition. Okay, now what happens? Your data, entire data, whatever you are loading the data into this Hive table will be stored as a single partition. Okay, when the entire data is getting stored as a single partition, is a single block for that particular matter, can you tell me what are the disadvantages what you have on that one? What type of disadvantages you have when you have the data within a single block? What are the disadvantages you have when you see the data in a single block?
So when you analyze data, you need to scan through whole of the block.
What is that one called? What is that process called? What is that process called? Is my question. What is that process called? Any idea? That process is called as FTS. That is what is called as full table scan. Okay, FST. FST or full table scan. FTS. Full table scan divya. Okay. Now, one thing what we need to understand here is, let me try to open this slide and then we'll start talking on this. Here is PowerPoint. If you are able to understand this one, this would be really good. I have the table, okay, which is having a department number. Okay, I have this employee number along with the employee name and then salary. Assuming that this is the data that is existing here. Okay, what is the talent text here? The talent text is top, and then we try to align this text with respect to the left like this. So you have this data. So assuming that what I told here, the department numbers what I'm having here are the department numbers what I'm having here are something like 200, 250 departments are there. Okay, and within each in that you have something called as employees, which are something like some 1,000 employees are there here. 1,000 employees are there. Totally, it is going to be 250,000. That is 250,000 employees are existing. When you have that many number of records, okay, obviously what happens is if I want to find out a particular record with respect to a particular, if I want to find out a record employee who is working in a specific department, then what I need to have? I need to do the full table scan. I need to do record by record check in order to really understand where that record is existing. So that particular process is really going to take so much amount of time. Okay, that particular process is going to take so much amount of time. So in such a case, what we want to do is that rather than trying to have the data to be stored as a single continuous block like this, what I want to do is that I want to split them like this. I want to split them. This is the second thing, this is the third thing, and this is the fourth one. I want to split the blocks like this. These are the 4 blocks I'm having here. Okay, assume that this is block 1, this is block 2, this is block 3, as well as this is block 4. Now, what is going to happen here? The department number what you are having here if I have this particular department number, based on this department number only, I'm going to partition the data. I'm going to partition data. How many types of partitions are there? Anybody is having any idea? How many types of partitions are existing? Hey, any idea how many types of partitions are existing, Divya? These things will be asked. You have something called as the key partitioning, you have something called as the list partitioning, you have something called as the key range partitioning, list partitioning, as well as the hash partitioning. Like that, you will have multiple types of partitions that exist. So whatever partition it is going to be, what happens is, based on the value, based on the value of that particular department number, suppose if we have a particular department number which is having some 10 values, 10 distinct values, 10 different partitions will be created. 10 distinct values, 10 different partitions are being created in this case. Okay, so in such a case, what we really want to do is that I'd like to find out the employees that are belonging to a specific department. I would like to find out the employees that are belonging to a specific department. In such a case, what I do is, there are two ways. Kamran, this was the discussion we were having yesterday. Remember?
Yes, I remember.
Yesterday I was telling you, I can try to find out the records in a particular partition specified by the partitioning name. Specified by the partition name. That means that what happens is that your data will directly go into your control will directly go into that partition for the purpose of searching the data. But the other option is, that you can also try to specify your where class with the help of that particular partitioning column also as well. Okay, what is that where class that you can specify? I can directly specify something like selector. Something like star from the department EMP table where department number is equal to something like 234, like that I'll specify. So either I can specify like this, or else I can define the partitioning name through which I want to get that data. So then this is trying to go into that specific table for the purpose of getting the data. So in such a case, what happens here? Your query execution time is going to be decreased. Your query execution time is going to be really decreased in this particular case, right? Now, can anybody tell me what are the disadvantages what you have here? What are the disadvantages you are having here? What are the disadvantages you have with respect to the partitioning of the tables? Please tell me. Kamran, Murli. Number of partitions could be high. Well, see, this partitioning is really going to work. Really going to work if your so-called partitioning key is having less number of distinct values. If your so-called partitioning key is having less number of distinct values, right? Less number of distinct values. But if in case if it contains more number of values, what happens is that the number of partitions that which you are going to split are going to be unmanageable, or else they are going to be uncontrollable, right? They are going to be uncontrollable. Okay. In such a case, what happens is that even though if you try to do the number of partitions, what happens is that from the storage perspective, the partitioning is not of that much usage, or else that much importance basically. That is the reason it is better to keep the data in a single table. It is better to keep the data in a single table rather than trying to partition that particular data. So that is the trade-off that we need to really take. That is the trade-off that you need to really take when you are working with partitioning tables or else with respect to the single tables. Shashank, is it clear or any questions you are having?
Yeah, Ravi, it's clear.
Okay, so now tell me whether you want to go with the partitions or you don't want to go with the partitions.
It depends on the distinct values of the partition key. If there are more distinct values, then we would not recommend partitioning. If there are less distinct values, then you will recommend partitioning.
There are less distinct values, so you obviously recommend partitioning. Okay. Now, one thing that you need to understand is who is going to control the number of partitions? Is the user going to control, or the partitioning column is going to control, or the number of values within that column is going to control? Who is going to control really the number of partitions in which the data has to be splitted? Who is basically controlling?
The user, I mean, if he specifies the partition,
it's not the user here. It's not the user. It's not the column also as well. It is the number of values which are there in that particular column is going to decide the number of partitions, right? It is going to decide the number of partitions. So in turn, it's not the user, right? It is nothing but the distinct values which is going to decide the number of partitions. You agree with me, Shashank, on this one?
Yeah, Ravi. I mean, we are specifying the partition key, right? So do we need to know the sample data of the data?
One minute. Of course, we need to do the definition. But who is going to dictate how many number of partitions has to be created? It's not me. It's not the database. It is nothing but the number of distinct values, right? Which is really going to decide how many values it should exist.
Yeah. Yes, sir.
That's what I'm going to tell you. Murali, you are on the same page, or you are in Tampa?
Yeah, Ravi. Can you hear me?
Yeah, I can hear you. You are understanding, right? What we are talking about here?
I got it. Yeah, but ultimately, whoever is creating the database definition is so. For example, department number, we know like how many distinct values of this department number exists. So do we need a partitioning on that or not? So ahead of time we know that, right? So
for some of the columns you know, guys. For some of the columns you know. Okay, but suppose, let me tell you, I'm trying to have something called as a product price classification is there. Price classification. Department number, I agree that that is a known value. Okay, but if there is something called as a product of price classification, through which that particular price classification I want to partitioning the data. How can I know beforehand that within this particular price classification, these many number of values are going to exist? That is something which cannot be decidable, right, Murali?
Right. So without knowing, we cannot go ahead and do partitioning, right, on that particular column.
If you want to go into the depth of database techniques, I'll also get into the depth of discussion. Okay, in partitioning, you are having a key range partition. Okay, you are having a list partition, as well as you're having the hash partition also as well. You also have something called as a modulus partition. Okay, now if you know the number of values beforehand, then in such a case what we do is that we try to go with respect to the key range partition or else with respect to the list partition. Okay, now if you really don't know the number of values that are going to be there, and if I'm not in a position to really decide which partition has to be used, I try to go with the guesses of the system. What is that one? That is nothing but the hash partition. Okay, what hash partition will do? The system will try to use its Kamran, please correct me if I'm wrong. The system, what it is going to do? It is going to internally fire an algorithm, okay, by passing your value as a parameter to decide the partition in which this particular record has to be inserted. That is basically treated as a hash partition. So that's why what happens is that in some cases we know the number of values that can exist over there. In some cases we know the number of values that are existing. In some cases we really don't know how many values will come. In such a case, if we really don't know how many values are expected to come, then in such a case we go with this particular system-based partitioning, which is called as the hash partitioning. Kamran, you agree with me?
Yeah, I agree with you. And yesterday, what I told that in the select statement partition, I checked like some of my like store procedure in existing where I work. So I noticed that the index name and the partition name they put the same. That's the reason I am also confused at that time. So,
yeah, that's why. That's the reason I just told you.
Yeah, it's the
That's the
same
reason
name.
yeah.
So that's the reason I a little bit confused myself also.
Yeah,
Without
the reason is that, the reason is that when I'm dealing this particular big data subject, simply going through this hive or simply going through this particular pig, we are not dealing here, right? The reason is we get into these particular things by having a vast research or experience on those particular platforms also as well, be it be application programming, be it be database programming, be it be business intelligence, or else be it be infrastructural virtualization also as well. All these particular things, when combined together only, these are the things that has to be discussed basically, right, Kamran? That's how these things
yeah,
really work out.
yeah, yes, right. And this concept is not easy to you can explain it. I know,
Uh,
like
this
if you are a
concept
good
is
DBA,
yeah.
good DBA, then the
So
DBA also don't know this thing in real.
the reason is that one more point I'll tell you before I proceed further. Uh, One more point. What I want to tell you here is uh, even the DBS also as well. At any point of time, may not be in a position to predict what exactly is happening. Okay, they also will have. They also will be clueless at some point of time. In which way we want to go. That's why they have a certain. They have a certain criteria, okay, that they want to do a test and trial before you want to really get into this particular activities. Okay, that's how we generally do it here. So whatever it is, the partitioning has a lot number of features. So if you really did want to get into the database, but since we are not getting into the database side, one thing that we need to understand is partitioning is a wonderful feature, beautiful feature, where it will try to optimize the query execution by not having a full table scan, but instead of doing that one, it will try to limit its searching only through a certain set of records only, through a certain set of records only. That is how this is expected to come in here at this particular point of time. Okay, now one more question here. Duja or Kamaran or Murli, please tell me whether this partitioning is a horizontal partitioning or else it is a vertical partitioning what we are doing here. Horizontal or vertical, this partitioning. Whether this partitioning is horizontal or vertical.
Is it vertical? I think so. Is a common column.
It is a horizontal, right? We are trying to have these blocks that are split into cuts here. What we are doing here, what I'm doing is that I'm cutting this block like this. This is one cut. This is second cut. This is third cut. Like that. This is what is a horizontal partitioning, right? Kamran, what we are doing here. This is a horizontal partitioning that we are doing here. Okay. And another thing is that partitioning is also having some disadvantages that we have already seen. Based on the column, in case if it is having less number of values, less number of distinct values, then only it is a good trade-off to do this particular partitioning. Otherwise, we don't want to do. Okay, but in order to overcome this particular shortcoming, also there is one more concept that has come. Shashank, can you tell me what is that one that we are talking about here? What is the other concept that we talked yesterday?
Clustering, Ravi.
Yeah, this is called as clustering. And what is the other name for clustering? What is the other name for clustering? Bucketing.
Bucketing, yeah.
Clustering or bucketing. Okay, here the first thing that we need to understand in this particular clustering or bucketing is here we are going to have the fixed number of partitions, fixed number of slots. Okay, suppose let me tell you, there is a particular column called as the state. There is a particular column called as the state. Okay, within this particular state, what I'm having here is I have something like India lo how many states unnayandi ippudu? How many states are there in India? Maybe 26, 27 or 28, 27 or 26. assuming 27 states, whatever it is. Shashank, can you gurtunda meeku? How many states in India?
29 and
రేపు అడిగితే మళ్ళీ 30 అంటారు, నాకు డౌట్ వస్తుంది దాని గురించి. Anyway, you are a citizen of America, so you don't know the states of India. Sorry to
అదేం
ask you. So, assuming that we have 27 states. I don't want to create that many number of 27 buckets in order to put this data here. 29. Okay. I really don't want to create those 27 buckets or 29 buckets in order to put this data. Here, what I want to do is that, assuming that I want to have something called as fixed partitions, fixed buckets, fixed buckets. That means that I myself will decide that no matter what values you are going to have, whether they are small values or whether they are big values or whether they are distinct values, okay, whether there are big values, what happens is I want to have all these particular values to be getting into any one of these particular 3 buckets. Okay, to be getting into any one of these particular 3 buckets. Either they may go into this bucket, or else it may come into this bucket, or it may go into this particular bucket. No matter what it is, I want to have these particular things that I want to go into this particular buckets like this. Okay. Now the question is, how can we do this particular bucketing here? Is it user defined or else is it system defined? User defined, can we do that one? And we cannot do that one, right? User defined. How can we do? I cannot direct a particular value to go into this first bucket, to go into this first bucket, to go into the second bucket, or to go into the third bucket. That I cannot do. Okay, for that particular purpose, see, one thing what you need to understand is that the place where the users are not in a position to decide, okay, into which particular partition the data has to be splitted, into which particular partition the data has to be splitted, that is a place where what I want to do is that I want to go with the type of partition, and that particular partition is called as hash partition. Hash partition. The type of partition is called as hash partition. Okay, and this particular hash partition, it uses a type of algorithm inside. That algorithm is nothing but the hash algorithm. It uses an algorithm called as the hash algorithm. Okay, and within this hash algorithm, what is the parameter that can be specified? The parameter that can be specified is nothing but the key to be used for bucketing. Okay, this is what I'm going to do here. Then modulus partition. Has anybody heard about modulus partition, Murli? Murli garu, మీరు modulus partition గురించి విన్నారా ఎప్పుడైనా?
No, Ravi. No hash partitioning, but not this.
Okay, modulus partition అంటే ఏమవుతుందంటే చూడండి, mod, what I do is that the number of buckets. Modulus is nothing but a reminder.
It always gives either 1, 2, 3, and that's all.
Yeah, either it will give you either 1, 2, 3, or else 0, 1, 2, whatever it is. Okay, it will give like this only. In such a case, what happens is that either it might be 0, modulus వాడినప్పుడు it might be 1. ఎందుకంటే 3 3 తో డివైడ్ చేస్తే మనకు వచ్చేది 0 కదా, 3 రాదు కదా ఇప్పుడు. అందుకని 0 to n-1 partitions మాత్రమే ఉంటాయి. In such a case, we go with this particular partitions like this. Either it is 1, 2, 3, or else it is 0, 1, 2 in this particular case. ఈ విధంగా డిసైడ్ అవుతుంది. దాని ఎగ్జాంపుల్ మీకు కరెక్ట్ గా తెలియాలంటే, వేర్ ఇస్ దట్ ఎక్సెల్ షీట్ హియర్? ఈ ఎక్సెల్ షీట్ లో one thing that you are having here is you are having something as a rand function. Rand function of 0, 100 if you see here what happens, equal to rand of, what is that value? It is equal to rand of, what is saying here? 0 and less than 1, greater than equal to 0 and number of 1. So changes on recalculation. So here I specify something like rand of greater than 0 or less than 1. Rand of 1, 100. I don't know whether this will work or not, but I'm just checking. Rand of 0, 1. ఇది వచ్చిందండి, ఈ వాల్యూ ఎట్ వచ్చిందండి. మళ్ళీ వెళ్ళి ఇక్కడికి వెళ్ళి ర్యాండ్ ఆఫ్ అన్నాను. అప్పుడే వాల్యూ వచ్చింది, ఈ వాల్యూ వచ్చింది. ఈ వాల్యూ ఎట్ వచ్చినప్పుడు ఇది ఇట్లా మళ్ళీ ఇక్కడికి వెళ్ళి ఇంకో వాల్యూ ఇచ్చాను అనుకోండి, ర్యాండ్ ఆఫ్ అని చెప్పి, ఇక్కడ ఏమే వాల్యూ వచ్చింది 06567 వచ్చింది. ఇలా ఇలా వచ్చినాయి. ఎట్లా మారుతున్నాయండి ఇవన్నీ? దివ్య ఎనీ ఐడియా? ర్యాండ్ ఆఫ్ ఇలా పెట్టాను అని మారుతూనే మారట్లేదు శశాంక్. శశాంక్
మారుతున్నాయి రవి, మారుతున్నాయి.
ఎందుకు మారుతున్నాయి అట్లా? మనం ఏమైనా చేస్తున్నాం లేదంటే సిస్టమ్ లోపల చేస్తున్నా?
సిస్టమ్ ఆ ఫంక్షన్ తీసుకుని
ఇంటర్నల్ గా ఒక అల్గారిథం ని ఫైర్ చేస్తుంది, అంతే కదా? అలాంటి అల్గారిథమే ఈ హ్యాష్ అల్గారిథం. అలాంటి అల్గారిథమే ఈ హ్యాష్ అల్గారిథం. సో ఈ హ్యాష్ అల్గారిథం వాట్ ఇట్ డస్ ఇస్ it will try to give you some value. Okay, that value, assuming that it is a non-integer, it is going to be a positive integer value. Okay, a positive integer value ne if I try to divide it by 3, suppose I'm getting the value as 5 I'm getting. Okay, suppose I'm getting this one 5 mod 3 enta avutundandi. What is the value of 5 mod 3 and what is the value of something like 17 mod 3 enta? 5 mod 3 and 17 mod 3, what are those values that you get here? Tell me. 5 mod 3 enta? 5 mod 3 is 2 and 17 mod 3 is also 2 only, right? 17 mod 3 is also 2. So అప్పుడు ఏమవుతుంది, ఈ 5, 17 అనేది ఏదైతే ఉందో దిస్ ఆబ్వియస్లీ గోస్ ఇంటూ దిస్ సెకండ్ పార్టిషన్ ఓన్లీ. సెకండ్ పార్టిషన్ లోకి వెళ్ళిపోతాయి జనరల్ గా. ఓకే, లైక్ దట్ వాట్ యు ఆర్ గోయింగ్ టు హ్యావ్ ఇస్ this bucketing is going to help you. Okay, so if somebody asks you well, what is the major difference between the bucketing or clustering of tables or the partitioning of tables, what would be your answer? Please tell me. What would be your answer if somebody asks what is the major difference between the bucketing and partitioning? అర్థమైందా మురళి అండ్ కమరన్? వాట్ ఈస్ బకెటింగ్ హియర్? What is bucketing? Is it clear to you guys here? Bucketing? Murali and Shashank.
Yeah, it is clear. Yeah.
Okay. Now another thing.
బేసిక్ గా బకెటింగ్ లో మనము నెంబర్ ఆఫ్ బకెట్స్ డిఫైన్ చేసి ఆ ఇంటర్నల్ అల్గోరిథం అయితే మనం ఏం డిఫైన్ చేయలేము. సో
ఇంటర్నల్ అల్గోరిథం నుంచి హ్యాష్ అల్గోరిథం which is not as per our rule. That is something that is something which system has to totally define basically. It's not our thing.
Sure, yeah. Thanks.
Okay, నేను అర్థం కాలేదన్నారు. You are comfortable ఇవాళ?
Yeah, Ravi.
Yeah. That is one thing. And second thing that we need to understand here is if we combine these two things, what are these two things that we want to combine? We would like to combine partitioning and bucketing. In such a case, the type of table is called as the clustered. The type of table is treated as the clustered partition table. clustered partition table. So I can do the clustering without partitions, as well as I can have the option of doing the clustering with partitions also as well. I can do it without partitions, as well as I can do with respect to these particular partitions also as well. So in the previous example, what we have seen yesterday, let me do one thing. In an example, did we create only partition, or we created these buckets also as well? Tell me now, Shashank. This is the thing that we created yesterday, right? Tell me whether it is a bucket or else it is a clustered index also as well.
We created clustered index.
We created clusters as well as we created partitions also as well at the same time. You don't need to మనం create చేయడం అనేది జరిగింది కదా?
Yeah.
So how this is going to work అనేది we need to really understand. How this is going to work here? I'm going to have 10 buckets, 10 states I'm going to have. Okay, within that particular state itself, you're going to have this particular partitions by this particular category. And how this diagram is going to look like, see here. I'm going to have a partition called a state. This is the bucket of state. This is the state bucket. So assume that this is the Florida bucket. Okay, Florida bucket. There is one more bucket here. Bucket. This is nothing but your Texas bucket. Okay. So Florida lo idru unnara. Murli meer Florida and Tampa ne kada? Texas lo idru unnaru. Inkokallu ekkada unnaru inka? Somebody is working in Canada. So Canada, we'll leave it for now. We focus on these two things. Ide Florida lo, what I'm having is that this is the Florida state. Within this one, what I do is that I start creating partitions like this. Partitions. ఈ partitions. ఇక్కడ మళ్ళీ 3 partitions. ఇట్లా నేను క్రియేట్ చేస్తాను. పార్టిషన్స్ ని I'll create like this. Okay, this is P1 partition, this is P2 partition, this is P3 partition. మళ్ళీ చెప్పండి, ఇది P1 అవుతుందా లేదంటే P4 అవుతుందా? ఇది guess whether it is called as P1 or P4 here. Shashank, Murli.
P1.
Whether it is treated as P1 only, right? It is treated as P2 only. It is treated as P3 only. So such type of thing, what you're having here is generally treated as what we do here. We call this one as clustered partition tables like this, as well as this one. Clustered partitioning tables. Clustered partitioning tables, right? Okay. Now, suppose what I want to do is that I would like to find out the list of all the records where category is equal to P1. Then in such a case, what I need to do, I need to get into this directory as well as I need to get into this particular directory also as well, right? 2 buckets I need to go, and then I need to find out each and every partition. Okay, in case if this state is not coming into the picture, okay, But if some state is coming into the picture, what I can do? I can directly go into that bucket and then get this particular category P1. Now, don't you think that is your data is getting much more organized in this particular case, Shashank? The data is much more organized here, right?
Yes, Ravi. Yeah.
So this is what is called as this one, which I was trying to tell you since yesterday.
Sure.
Kaplan, is it clear now?
Yes, sir, it's pretty clear.
Okay. Now we'll see what are all the steps that we will need to do in order to implement such type of partitions here. Okay. See, a query across all the partitions could trigger an enormous MapReduce job. You are seeing here, right? What is happening here? For even a simple query itself within Hive is taking so much time. But the same query when executed in Oracle will take less time basically. Will take less time. 1 minute, please. Okay. So one thing what I was telling you here is if your query is, even though if it is a simple query, what it does is that it is going to have an intermediate MapReduce job that is going to be created, and that itself is going to take a hell of time. Okay, but if your query has to get into each and every partition, okay, for the purpose of combining all that particular data, it is going to trigger so many number of MapReduce jobs, right, Shashank? When the partitions are very large, then it is going to trigger a large number of MapReduce jobs it is going to create. So that is the reason what we can do is that we can try to enforce some restrictions. What are those particular restrictions are? Listen here. Whenever a particular query is being filed on a partitioning table, what I want to do is that I will always specify that that query need to be associated with the where class. The query obviously need to be associated with respect to the where class. Okay, if that query is not executed with respect to the where class, automatically what happens is that the query will not fire at all on those particular partitioning tables. So that's why what we can say is that a highly suggested safe measure is putting Hive in the strict mode. Uh, okay, that will prohibit the queries of the partitioning tables without a where clause. So that's why, in case you can also put it as a strict or non-strict. We'll see that particular code very shortly. But obviously, what I'm trying to tell you is that you can have the option of making your Hive to work with the where class as well as without the where class. To work with the where class or without the where class also as well, based on the select query what you are going to file, we are going to set some environmental variables. So what are those environmental variables? What we are going to set is something that we will see, and then we'll take it further. Okay. Okay. set hive dot xac dot dynamic dot. You please note down these things, guys. Partition dot mode is equal to non-strict. Okay, and again what I do is that set hive dot exec dot dynamic dot set dynamic dot partition is equal to true. Partition is equal to true. This is the second one. Third one, what it is that set hive dot. These things are very, very important, guys. They are going to ask you. Divya, especially for you. Enforce dot bucketing is equal to true. These are the three things. So Shashank, what is the first one? What is the first one telling?
So you're putting it into non-strict mode.
So when I put into the non-strict mode, what does it mean?
You can either use where clause or you cannot use where clause. There's no compulsion to use that.
There's no compulsion for you to fire the where class on those particular partitioning tables. That is first thing. Okay. And second thing is that I'm also going to specify partitioning is equal to true. Obviously, what happens is that I am invoking your partitioning mode to be active. Your partitioning mode to be active. Okay. Especially when you are trying to execute your queries. Okay, that means that not only the full table scan that you need to do, there is partitioning that is already embedded in that one. So you please make sure that your partitioning is aware of working on this particular data. That is the second thing. And what is the third thing that I'm telling here? Even bucketing is also available. Okay, if you can see this particular statement, Murli and Kamran, if you see this particular statement, what is the statement here? Create table of this one. It is containing both these two things. It is containing the bucketing as well as it is containing the partitioning also as well. Okay, now if I want to execute or insert any data on this one, I want to make sure that these are the three environmental settings that I want to do. Okay, before I go ahead and then start loading the data into the partitioning table or trying to do any type of data swapping that I want to do, that is going to be completely based on this particular settings only. Divya, is it clear to you? Is your voice not available today? Divya or Kamran? Murli?
Yes, it's clear.
Okay. So in the next session, what we do is that we'll go ahead and then start working on those particular queries that is going to give you the performance enhancements. Okay, in terms of what you do and what is expected to be done. All those things we are going to see in this particular things, and then we'll be taking it from there. Okay. Any questions you are having here, please let me know.
Ravi? Yeah, I was trying some simple queries on the Hive yesterday. So it's giving me some problem. So can I just copy paste that query to you? And it's not like big ones, small ones I'm trying.
Show me that query once.
So it is like we have that transaction records table, right? So I did create table on TXN records, and I was just trying to select the customer number and product from transaction records who has spent maximum amount. So
okay.
So I wrote like select customer number product from TXN records T, where T dot amount equal to another subquery, select max of amount like that. Does this subqueries work in Hive or
No? We have to do it with the help of joining and all. But if you have a couple of settings that are to be done, it will be able to do that one. Okay. Subqueries. Can you send me that particular query to me?
It's not very big. I can put it in chat actually.
Show me that one.
Yeah, I'm typing it 1 minute. So something like that. I was trying to just select one customer number and product.
It's not working out, huh?
Yeah.
1 minute. What is the high version of your thing? Can you please check? What is the high version that you are using?
High version. Okay, 1 minute. What's the command to check the version?
Hive version.
I should come out of this Hive shell, right?
Even in the Hive, you please check whether it is working or not.
It's not working there. No, it's not working like that. So it says.
Those are the ways. See, if you want to create a subquery, okay, it should be like this. It should have something like select star from another subquery. It is not something like select star from so and so where something is equal to, that thing is not there. That thing is not there. Okay, in case if you want to use something called as where, either you can have the option of using this particular relational operator in, or those things we can use. But even this should work out.
Because max of amount should give me some number. That's all right. One record. It's like amount equal to hard code.
If you find this select a max of amount from TX and records, you'll be getting that value, right?
Yeah, so, independently I'm getting, yeah.
Okay, let me try this one and then I'll get back to you, Murli. Let me try that one from my side.
Okay.
This subqueries. Maybe tomorrow morning or sometime I'll get back to you and then we'll take it from there. Okay. It should work out basically. It should work out. Why this is not working? 1 minute.
Mine is got closed just now. So I was just trying to find out the version and
I use this one. 1 minute. And tell me this query here. You tell your query here once again.
Okay, select customer number CUSTNO. So you see that yeah, describe table you have that above just now. A customer number, product. For now, from TXN records. T
T ఎందుకు ఇంకా?
Yeah, we don't need. I was just trying that also. Without that also it didn't work. Where amount equals.
Where amount is equal to
Select
max of
amount. Yeah. From TXM records. So I think you didn't load the after create table. Did you load it?
Yeah, I loaded the data. Yeah. Where amount is equal to select max of amount. TXM records. Cannot. This is the same thing that you are getting here. Cannot recognize
right.
input here.
Or do we need to have that amount in the select list?
Where amount is greater than, shall we put like this? Where 1 minute. Something one day select amount in select amount just for an arbitrary purpose I'm doing. I'll do like this and that's it. Where corresponding line let me try and then I'll tell you. Mine is not working now.
Okay. No.
Yeah, sure. Okay. I'll tell you, I'll check and then let you know. Okay. So these environmental variables are okay with you, right? The settings what I did. Okay. Okay, guys. See you. Have a good weekend. See you on Monday.
Thanks, Ravi. You too.
No problem.
Thanks, sir.
Yeah.